Hey everybody, welcome back to another round of astronomy, and yeah, let's get going. Displayed for you here are the phases of Venus, and that discussion will come back into the Ptolemaic model as we progress to a more accurate conceptualization of the universe. So we're going to set this aside for a moment because the thing I want to focus on are phases and what kind of information we can infer from the phases of an object. Now, I won't be talking about Venus, but rather I'll talk about the moon, since you've probably heard, or at least are familiar with, the phases of the moon. Okay? So first off, we'll start off with a really cool historic image. This is known as Earthrise, and it was taken by the Apollo 8 astronauts on the first trip of humankind around the far side of the moon. Now, the question I have for you is, where is the sun located in this image? You got it? Yeah, good. And so you say, well, how do I get that information? Remember that the illuminated portion of an object is due to the sunlight striking the surface of that object. Okay? So the Earth does not emit light, right? It is not emitting a bunch of light out into space that you can then receive when standing on the moon, for example. The majority of the light that you're seeing here is coming from the sun and bouncing off the Earth and reflecting to us. Okay? And it's like that for any of the astronomical objects, the planets, the moons, not stars, to be continued, but any of the other astronomical objects. This is primarily how we can see them. It's light reflecting off of their surface. So where's the sun located? It's got to be up here somewhere. Now, the thing I want to highlight for you is notice, okay, this is a slight byline, notice that the reason you can't see this part of the Earth is because the sun is on the opposite side, right? The reason you can't see this side of the Earth is because the sun's over here. Okay? It is not because the shadow of the moon falls on the Earth. Okay? I'll repeat that. Okay? You see only a portion of the illuminated Earth because the sun is over here. Okay? Not because the shadow of the moon is falling on the Earth. Okay, good. So as long as we're clear on that, that's just a byline. So here's another question for you. Thinking about the Earthrise image, you have the sun, you have the Earth, you have the moon. Okay? Thinking about this Earthrise image, now I am going to go to a different vantage point. So let me explain this vantage point. Okay? What we're going to do is we're going to hop in our spaceship, okay? And we are going to fly out to the celestial sphere at a particular location. It is going to be at the north celestial pole. Okay? So you can imagine we're on our spaceship at the North Pole. We launch straight up to the north celestial pole, and then we're going to turn around and we're going to look back at the Earth. We're going to look at the moon, and we're going to look at the sun. Okay? So we can see those three objects. Okay? Question for you. Okay? This image of Earthrise that we have on the left, okay, for which position of the moon, A, B, or C, corresponds to this Earthrise image? Okay? So go ahead, take a second, see if you can hack out an answer. So if I were standing on the moon, okay, and I have to point at the Earth and I have to point at the sun, okay, you have some angle between your arms, right? Now let's go through. If we were at position A, okay, and you're standing on the moon at position A, you point towards the sun. which way would your arm have to be pointing in order to point towards the earth? Yeah, directly opposite. Well, in the picture, it's not 180. So position A can't be the right position. Well, how about position C, as in cat? Well, let's go ahead and think about that. If I'm standing on the moon and I point towards the sun, I should also, and I point towards the earth, you notice now the angle between my arms is 0, which again doesn't jive with what I see here in this image. I point to the earth, I point to the sun. It's a non-zero angle. So C can't be right. Well, let's think about B, as in boy. If I'm standing on the moon and I think about pointing towards the earth, okay, I point this way, and I point towards the sun, I get some angle between my arms that's greater than 0 degrees. You know, it's greater than 0 degrees, but it's less than 180. Now, you could probably approximate even more. But that's good enough, okay? So let's say now that the moon is at the position A. You know, the moon is right here. And you are standing on the earth. Okay? Next question for you. How much of the illuminated portion of the moon will you be able to see? Survey says none. Good, right? Remember, the phase of the moon, the amount of light that the moon reflects, well, it is going to be the portion of the moon that is facing the sun. Just like we saw over here in the left image. The illumination is caused by, or the illumination is caused by the sun. That means the illuminated portion always faces the sun. Well, if you're standing on Earth, you can't see that illuminated portion, right? You only get to see the portion of the moon that isn't illuminated, right? So you see none of it, okay? Oh, incidentally, if I point at the moon and I point at the sun, what's roughly the angle between your two arms? Yeah, good, 0. Yeah. I should say, when the moon is in a position that we cannot see any of its illuminated portion, we call that a new phase. Okay. And the connection, so that's the terminology, can't see any of the illuminated portion. And the connection I want to make is that the angle between the moon and the sun is roughly 0 degrees, right? If it's a new phase, you point at the moon, you point at the sun, the angle between your arms is going to be approximately 0. Okay. Well, how about this? How about if instead you're standing on the earth? Okay, the lettering's in the way. So we'll just say you're standing on the earth over here, and the moon is at position C, as in cat. How much of the illuminated face would you be able to see? Yeah, unless it's a lunar eclipse, to be continued. Okay? If you're standing on the earth at this position, you're looking at the moon, which is at position C, you should be able to see all of it, right? That's like a spotlight being here. Greg is the earth, and then the moon is over here, right? You get all of the illumination from the spotlight standing behind you, kind of goes over your head and illuminates the moon. So you should be able to see all of it. Okay. We call that a full moon. So that's called the full phase. Incidentally, if you point at the sun and you point at the moon, what's the angle between your two arms? Yeah, good. It's roughly 180. 180 degrees. Good so far? Yeah, good, good, good. Okay, well, let's keep going. Okay. If it's at position B, as in boy, and you're standing here on the earth, how much of the illuminated face can you roughly see? Yeah, good, good, good. You see, so you can see about half of the illuminated face. Okay. Now, we don't call it a half phase. Okay. We call it a quarter phase. Oh, I should ask you this. Is it going to be the left half of the moon or the right half? Yeah, good. It's the side that's facing the sun. So if I were standing here, that would be the left-hand side. Corollary question. Where is the first quarter position of the moon? Yeah, you got it? Yeah, good, good, good. Well, third quarter, 3/4 of the way around. First quarter, 1/4 of the way. That means the moon would be over here on the right-hand side. Again, what's the angle? Yeah, 90, good. And instead of the left-hand side of the moon being illuminated, it's gonna be, yeah, the right-hand side. Yeah, so a first quarter. So that's how you can tell a first quarter or a third quarter. The first quarter, it's the right-hand side that's illuminated, whereas a third quarter, it's the left-hand side. Good? Yes, you do need to know this. And please, I beg of you, start going out and looking for this. Okay? So go outside, start looking for the moon, think about where the sun is. If you have to, point at the two and start looking at the angle between your arms. You'll notice that the phase of the moon is related to the angle between your arms. What I like to say is that the phases of the moon are caused by the relative position between the sun, the observer, Earth, and the moon. Okay? That is what causes the phases. So I've got just the other terminology, but you start off with a new phase here on the right-hand side. And again, the moon is going to be moving counterclockwise in its orbit. Okay. And so as you go from seeing nothing to slowly seeing more and more. Okay. Now it's going to be the right-hand side that's illuminated until you finally see a full moon, right? All of the illuminated face. Well, you can't see more than all of the illuminated face, right? You see all of it. And so for the latter half of its orbit, you're going to notice the illuminated portion getting smaller and smaller and smaller. Now, the terms that we set up for this, if the illuminated portion is growing, we call it a waxing phase. Okay? If the illuminated portion is shrinking, we call it a waning phase. I believe waning is this old kind of English word for, becoming faint. I wane, kind of like swoon, I believe is an analogy. Okay? So waxing, the illuminated portion is getting larger. Waning, the illuminated portion is getting smaller. Okay? Now we have a second set of terms here, crescent and gibbous. Okay? If it's between a new and a quarter phase, it is a crescent. That shape of like your thumbnail, right? The white part of your thumbnail, crescent shape. Okay? If it's between a quarter and a full, we call it a gibbous phase. And so you have 4 possible combinations, right? 2 choices, waxing or waning, and 2 choices, crescent or gibbous. And those 4 possibilities will tell you what the phase is. That's how you describe the phases. Bear in mind, if you can't remember waxing or waning, remember that if the right-hand side is illuminated, it's in a waxing phase. If the left side is illuminated, left-hand side, it is a waning phase. For additional completeness, Oh yeah, let's do a, guess I could do a demo here. I apologize, the video is a bit hard to do it. I usually, if I were in class, I would hold this here and I would walk around you all the way. Unfortunately, I can only do half of it. So, c'est la vie. So let's go ahead and say that the red side of this ball is the illuminated phase of the moon. You are the Earth, and I'll set my window here as being the sun. So first thing, I have to make sure that the illuminated portion of the ball always faces the sun. So I will step back a little bit further. Illuminated portion is facing the sun, and so you should ask yourself, what phase is this? Okay. Have to think, is the right-hand side or the left-hand side illuminated? And you'd say, oh, it's the left-hand side. So this must be a third quarter. Well, okay, right now it looks like it's more like a waning left-hand side and gibbous. Notice you can see more than a quarter of more than half of the illuminated portion. Okay, so we have a gibbous phase. Now I'm just going to start orbiting counterclockwise. And as I do that, oh, right about here, you notice now you're in a quarter phase. I haven't done anything fancy, right? All I've done is just shifted the relative position between the sun, the window, you, the Earth, and the moon. And as I keep going, you'll notice, okay, now you're seeing less and less. We're in that crescent phase until I finally get here, right? It's not that the shadow of the Earth is blocking light from reaching the moon. Oh, nay, nay. What's going on is that the illuminated portion of the moon is just facing away from you. Now I could keep going. If I kept walking around behind you, you would see it start in the waxing phase. And then it would hit first quarter, and eventually it would hit a full, and then it would come back into your gibbous phase, waning gibbous, going to a third quarter, and going back to a new. Okay? Yeah. Okay. Now the next thing, I know I beg of you, go outside. How do you succeed in this class? Number one, go outside, take the information you're learning in lecture, and start seeing if it jives with what you observe. So aside from going outside and practicing the star chart, okay, the next thing that you need to go out and look for is look at the moon. Look at what time it is, look at where the moon is positioned, and see if you can go out a couple nights at roughly the same time and look at where the moon is located. Okay? I guarantee you, you will actually start seeing the moon changing positions every night, and you will start noticing that changing phase. Okay? Okay. So, I'll go ahead. Let's wrap this. I've got another. Okay. So I've got another little comment. Okay. Notice we already talked about the new phase being roughly at 0 degrees. First phase, the angle between your arms is 90. The full phase, it's 180. Okay. Now, third quarter, you could go either way. I guess you could say that it's 270, right? You started here, you wrapped all the way around until you're 270. Most people won't do it that way. They'll start counting down from 180. So they'll go back to 90 and then to 0. Either or is fine with me. Okay? So the question then becomes, for a waxing crescent, what's the angle between your arms going to be? Yeah, good. It's going to be between 0 and 90. Okay, not a trick question. I just want you to, give me the answer. So the waxing crescent is going to be between 0 and 90 degrees. Notice it's a wide range. Okay, and it'll stay in the waxing crescent for about 7 days. First quarter is a specific instant in time, so you could think of this as being 1 day. Waxing gibbous, the angle is between 90 and 180. And again, this will be about 7 days or so. Full, it's a specific moment in time. So this is again a day. And then you can kind of see the pattern. Waning gibbous, again, it's going to be, I'll put it like this, 180 to 90 degrees, okay, for roughly 7 days. Third quarter is a single day. And if you really want to get specific, these are not only a single day, but a specific instant in time. And then, of course, the waning crescent will be 90 to 0 degrees. Okay, so I think that's all I have for you for this discussion, okay? The key ideas: the phases are caused by the relative position of the sun, your observing location, usually we think about the Earth, and the object you're observing. Okay? That's number one. It is not due to the shadow of the Earth on the moon. Okay? Number one. Number two, and this one I really need you to latch on to, we can associate specific phases with angles. I'll say that again. We can associate certain phases with angles. If I see a first quarter phase, I can say that the angle is 90 degrees. If I see a waxing gibbous phase, I know that the angle is greater than 90, but less than 180. Okay? So I need you to latch onto that key point because we're going to use it in the next lecture. Okay? Yeah, good. So practice the terminology, the phases, go out, look at the moon and say, oh yeah, it's in a waning gibbous, okay, or a waxing crescent, and take a stab at it, okay? Don't have to be right. Nobody's around to grade you, but look at it, see if you can practice those terms and start identifying what the moon looks like, okay? Hey, I thank you for your attention. Keep up the good work. I'll see you next time.